How's it going, YouTube? My name is Johnny Bannon with Trepid Technologies. It's 11 o'clock at night here, and I'm here to teach you some route filtering with EIGRP. So click that link below, and let's get started. Alright gang, if you hit that link below, you should be at our Confluence page. And today we're going to be doing some route filtering. So if you follow our Confluence page at Trepid Technologies, you'll know that we build a whole how-to space with different technologies. So today is route filtering in the EIGRP and all the different implementations. This is not all of them, it's just a few. So we're going to be using a lot of distribute lists, referencing ACLs and prefix lists. And then we're going to set administrative distance, and then we're going to set route tags. And we'll actually implement route maps with these three. I believe with this one we might. So first things first, let's go down here. First we're going to set up our Genus 3 environment, and then we're going to add a base configuration to all routers. So typically in my videos, I go to VS Code, right? I clone a repository, and then I show you guys the applets I use to baseline my routers. Today is going to be a little different. So today I'm going to go into Genus 3. I actually have an Ubuntu image right here. It's actually just a Docker guest with Ubuntu image that already has some network automation Python libraries on there and Ansible. So I didn't have to install Ansible. So we're going to get into here. Let's look at what we got. So this is what I'm going to clone, but I'm going to start from the beginning with you guys. I'm going to remove this recursively. Okay. So what I'm doing here is I have an Ubuntu computer here. I got to baseline all my routers. So I am going to clone the repository I use for Ansible. So if I go back to GitLab and all my projects, this is the repo I'm going to use for when I'm actually in the Ubuntu image in Genus 3. So just like the other one, we're going to do a git clone, but instead of doing this all from VS Code, we're going to do it via command line. So the command is git clone, and then your GitLab URL. Now if we look here, we can see that we cloned that repository. So let's change directory, right? Get in there. And what's the first thing we're going to do here? So if my routers weren't already baseline, I would put basic IP configuration. I would make sure that they can all talk, and including talking to my Ansible server, which is my Ubuntu Yes image. And then I would type in Ansible playbook baseline.yaml. But I know they're already configured, so I'm going to skip that step. But if you want to look at it, let's actually install that. Apt install tree. Let's see if we can install tree, guys. So I'm going to come here, have an install tree Ubuntu. I think that's the image. It should be sudo either apt install or git apt install. Looks like they want us to use a snap. We don't want that. We just want to install tree using apt. Here we go. Sudo apt-get install tree. Let's do it. Sudo. I don't think I have to put the sudo here, but we'll see. Yes, that was correct. That's because we don't have a super user actually. That's okay, guys. We don't need to install trees. Let's make sure I can actually ping out though. That could be our issue. Can't ping out. That's okay. We can just do this without that fancy tree command. So if you look here, this has all my Ansible repository that you may be used to seeing in my past videos. So now let's go back to Confluence. Let's look at step 3. So we know the baselines are there. If you want to go through the Ansible folder structure, you can. And then stay tuned. I also will have a whole video series on Ansible. So now we're going to configure name EIGRP on all routers. So what I'm going to do here, go back to GNS3, back to my Ansible server. And let's look at some of the playbooks we have here. I have a playbook called named EIGRP. Let's look at its contents. So here we're configuring EIGRP for these hosts, whatever they are. And I'll tell you, this is a group in my inventory/host file, and this is also a group. And these have all the routers. So if I want to configure named EIGRP on every router, I can run this playbook. The way we do that is type in Ansible playbook, named EIGRP. So let's see if it runs. So my router should have OSPF connecting all them, and they should have SSH enabled so that we can talk all across the network. If we get an error here, let's go ahead and console into that router. And I think I know the issue. Unable to connect on port 22. So I guarantee this is just an SSH issue. I'll show you how to confirm that. You show IP SSH. Please create RSA keys to enable SSH. So let's do it. We don't have SSH enabled on here. And that should be part of my base config. But for some reason on some of these routers, and again, we're in an emulated network, it just won't create the SSH keys unless you do it yourself on the CLI. Let's go back to our Ansible server, which again is just Ubuntu. So now we have named EIGRP on all of them. The next thing I'm going to do, guys, is actually get rid of OSPF on this network. I just want EIGRP for this lab. So again, let's take a look at this playbook called no OSPF. Type in more no underscore OSPF. Okay. So guys, see this host right here? I left this intentional. We need to change this. There is no group of routers in my host file called routers underscore EIGRP. So what are we going to do to change this? Here we're just going to use Nano. I know Vim and VI is better. It's more complex. You talk to hardcore coders that make fun of you for using Nano. But it'll work for these purposes. We're going to change this host right here. Those are the two groups we need to hit all the routers. Hit Control O to write to the file, Control X to exit out. And now we'll run it. So you may be wondering, since we made a change here on the local repository, don't we need to push it up? And you're exactly right. OSPF is actually how we communicate outside this network though. So once this lab is over, the actual route filtering on EIGRP lab, what we came here for, I'll put OSPF back on all the routers, get rid of named EIGRP using two playbooks, super easy. And then we'll do a git push, and we can see our changes be actually staged, committed, and pushed to our repo in GitLab. So now our routers, if we do a check here, should have just EIGRP running. Show IP protocols. And we just have EIGRP running. Great. So now we're done with the automation section of this lab. Let's get into the route filtering part. So the first thing we're going to do here is we're going to go to R8 and filter the loopback address coming from R10 based on an ACL. And that ACL will be the reference that our distribulist uses once we configure the distribulist under the named EIGRP process. So let's go to router 8. Let's look at what we got here. First, we'll just do some show commands, see what we're working with, look at our routing table. We have connections to router 5 and router 10. That's good. Looks like we have all the routes, all the loopbacks, and we want to filter this one out coming in on our gig 0 interface. So what we're going to do here is we're going to get into the named EIGRP mode. And again, for you guys that don't follow my videos really strictly, what I did there was you do show run, you do // and you can search for anything in the running config that way. So now We're actually in the topology base, so that's good. So we're going to do distribute list. And this would be the name of the ACL. So we'll just create the ACL after this. This is actually a test to see if we have to do this stuff in order. I don't think we do though. We're going to do it in on gig 00. So that shouldn't be doing anything because we haven't actually made that ACL yet. So let's remember the name we gave it here and type in that ACL. So we're going to do IP access list standard name. Actually looks like we did have a resync from that distribute list. So before we make this, let's just look at the routing table and see what happened. Seems like there was just a resync, but it didn't actually do anything. Alright guys, fair enough. Let's keep doing what we were doing. I don't know why that happened. I think just because we made a change to the actual EIGRP process, it's going to do a resync, but it didn't actually do anything. So I bet if we looked at those packets on the wire, it would just say that there was a distribute list added, or actually it'd probably just say nothing, just a change in the local topology, but no other flags were sent or anything was actually changed. So let's deny that route. Then we're going to permit any. So let's see what we got here, guys. Show IP route. EIGRP. So looks like we're still getting that in. Oh, here we go. Now we got out of the resync. Now it's no longer there. So if we do show IP route 150.1.10.10, subnet not in table. If we come here to our Confluence page, we can actually see that router 10 is actually sending that route over to us. You can see that this EIGRP update packet is coming from router 10 to the EIGRP multicast address. But even though it's getting sent, R8 is denying it when it comes in on gig 0. Let's move on to the next step. Now we'll configure distribute list referencing a prefix list to our filtering. Again, we're going to be doing this on R8. So what we'll be doing here for this one is we'll only permit hosts with a /32 prefix mask. Or I guess you could just say prefix. So one thing we can do here on Detroit is actually, let's not do that. Let's go into global config mode. Do show run /EIGRP. Let's get into that and get rid of that distribute list. Type in no, copy and paste this distribute list. Boom, awesome. So now let's go back to global config, make our prefix list. So IP prefix list, not host, deny any IP address. So this is how you do any IP address. Now let's specify its mask. So any IP address with a mask of /31 or less will be denied. We can see that deny right there. Now let's permit the /32s. So we'll do the GE32, and that's equal or greater than to 32. So really just 32. And then we're going to go into name mode again. Just come back up here, copy, paste, enter. Now we'll type in distribute list, the prefix, the name of the prefix, not host. And we're just going to do this in on all interfaces. So let's see our neighbors resync, and then let's go into our routing table and see that we should only have /32s. So show IP route EIGRP, and all we see are the /32s. Awesome. That was too easy, right guys? Now we're going to set router 10's loopback address to an administrative distance of 255 on gig 0 on R8. So this is where we're doing all of our route filtering, guys, between these two routers. So what we're going to do here is, again, reference that loopback address using an ACL. This time we'll just do a numbered ACL, show you a different kind of syntax. We'll get into named mode, do show run, / EIGRP. We'll get in here. Type in no, get rid of that old distribute list, come back up here, copy, paste, enter. And then this syntax is actually going to be distance. So let's set it to 255. And then the syntax is a little weird, but what we're going to do here is do all IP addresses and then based off ACL1. So we're going to say, hey, every IP address only referenced by ACL1, set the distance to 255. So that means we should only have an administrative distance of one route coming in, and that will be R10's loopback address. So let's see if that took. We'll do show IP route EIGRP. I don't see it initially in there. Let's actually check the route itself. All right, let's check the Ceph table, guys, just to see. We'll actually put the address in, see if we can still. So actually no route in the Ceph table either. So that means the actual forwarding information base. We all know Ceph is Cisco Express Forwarding and actually does the recursive lookups. We know that, right, guys? Of course. We actually also do show IP EIGRP topology. No entry even in the topology table. Completely denied. All right, now we're going to do our last form of route filtering. What we're going to do here is use a prefix list and a route map. And we're going to set a tag on that loopback on R8. And then we're going to go to R7. We're going to verify that there is actually a tag on that loopback. And then using a route map, we're going to match that tag, so any route with that tag, and we're going to deny it out to router 9. So if we go to our topology, we're setting a tag on a route coming into R8. And as it goes through the entire EIGRP autonomous system, router 7 is going to have a route map that says, hey, any routes with a tag on it of 10, deny them out to Boston R9. So let's do it, guys. This one should be fun. So we're going to start on R8. The first thing we're going to do is do route map. Actually, hold on real quick. Let me just look at something. Here we go. I wasn't looking right for a second. I knew we had to base it off a prefix list. So first we're going to make that prefix list. All right. We'll call it R10 loopback. Permit, and this is just a way to reference it, right? That IP address with that mask. Then we're going to actually do the setting here. So we're actually going to set the tag based off the IP addresses referenced in that prefix list. That syntax is match IP address, prefix list, R10 underscore loopback. So we're going to set it, set tag, so the match and set syntax we use for route maps, right, guys? Then we're just going to do another permit any for the route map, you know, sequence 10, sequence 20. And that's just like a permit any. And then I'm just going to come over here and copy this, since we already know how to do it in the show run, right? And then we're going to make a distribute list. And we're going to set that tag on the inbound interface, which we know is gig 0. And that is the connection to router 10 actually sending the route. Awesome. Now let's go to R7. We're actually going to make sure that there is a tag on that route. Looks like it's not in the or the routing table yet. So we might have a problem, but I'm pretty sure it just has to resync first. Actually, it's because we did not get rid of that distance. Do you remember we set the distance for it? Yep, we have to actually type in no, because that's actually not allowing that route in. So we got to get rid of that. Let's have EIGRP resync. Here we go. It's up. And now R7 should see that route. Awesome. And here we have that route tag. So now let's go into R7. Let's create that route map. We'll do deny tag. We'll do a deny statement actually. We'll match the tag itself. So this would be any route, right guys? We're gonna match it. And since we already did the deny, we don't have to set anything. And now we'll make the sequence 20 of our route map, just a default permit. And now we go into named EIGRP. And we're going to set a distribute list outbound to router 9 based off that route map. So route map, deny, tag out, gig 00. Almost done. Now we go to R9, console in. First we're going to have to log in. Gotta love emulated routers, right? Now let's do show IP route 150.1.10.10. Nowhere to be found. Alright guys, that's it for the actual route filtering. If you want to stay and watch me actually use 2 more playbooks to get rid of named EIGRP and put OSPF back on, or actually different order of sequence, but essentially use playbooks to get myself connected to the internet again, and then push our Git repo that we made changes to, and then actually go to GitLab and see those changes on the actual website, then stay tuned. If not, thank you for coming, and I appreciate your viewing. Let's get back to some automation fun. So now that we did over our route filtering, I'm going to go into R8, just get rid of that named instance and redo it real quick, just so we can have something clean. No router. Router EIGRP, name mode, address family before, unicast autonomous system 1. This one I'm just gonna, since I don't like making super long videos, guys. Awesome. Now let's go to our Linux, our Ansible server, right? Which is just Ubuntu. First thing I want to do here, guys, is do git stage all. So what this does is actually stages your changes that you made. And now we're going to do git commit, and our message will be fixed stuff. So here we see we actually committed those changes to the master. So first we got to stage, then commit. Now we got to push. But if we try to ping out, it's going to be no bueno. So let's just stop that right there. First thing I want to do is make sure I have the playbook to actually put Ansible or OSPF back on. I believe that's the one. So let's actually look at it before we run it. Yes, it is. See the little configuration change. Boston router has to do this default information originate to make a default route out to it. So all routers. And then the rest get this right here. So first playbook I'm going to run is actually the OSPF one. It's called internet.yaml. Let's pray that it works, right? Always a good sign right there. Our second task, configure OSPF on R9, and it took. Awesome. Now let's do our second playbook. hope I made it. If not, no issues. All this playbook is getting rid of named EIGRP. Here's what we can do, guys. Let's go into this one. We're going to copy this. Let's exit. Let's make the new one on the fly right here. I thought I made one earlier, but I probably didn't actually save it. We don't need any of this. All we need is one line saying no router EIGRP Johnny. Control, fix that comment. Control O, write it. Let's exit. And now let's run it and let's pray that it works, right? Here we go, moment of truth. All right, easy day, right guys? So now let's make sure we can ping out. It's actually just ping gitlab.com, of course. Awesome, we can ping it. So now what we're gonna do here is to git push, I believe the syntax is origin -u origin master. All right, here we go. It's asking me for credentials. And now those changes that we staged and committed are getting pushed to the master branch in our GitLab. Let's check our GitLab and see if those changes actually took. And as you can see here, they haven't taken yet. So let's just give it a few more seconds. Let's see what's going on. Looks like it should have worked. We'll just do git push origin master. Let's see if that makes it work, guys. Password. Okay. So we should be seeing this actually in our repo, and we're not. Let's see what's going on. Well, okay guys. On my next video, I'll show you what actually what's going wrong right here. I think I'm not staging them all, but I'm also not sure. It should already be initialized. Do it one more time. If not, then we'll be done for this video. Well guys, sometimes it's just how it goes, right? Let's go to our projects. Maybe I put it in this one. Nope. Go to your projects. Updated 2 minutes ago. It's saying it's getting these updates. But I'm not sure why it's not putting that new playbook in there. Let's see if that playbook's actually should be right there. Well guys, that's okay. On my next video, I'll actually do more troubleshooting and see what the issue was. But as of now, I'd like to thank you for viewing and remind you to keep learning every single day. Thank you.